Yeah, hello students. Welcome to P&M Tuitions online classes. Yeah, so today in this video class, we are going to understand scattering of light. What is that? What we are going to understand? So we are going to know about what is that scattering of light. So what is this scattering of light? Scattering of light, generally, normally, what is the meaning of this scattering? Scattering means what? Spreading. Spreading of what is that? Light in all directions. So spreading in all directions is called what is that? Scattering. What is the meaning of this scattering? What we can understand? Spreading in all directions. Spreading of, who is spreading? Light is spreading. That's the reason this is known as what is that? Scattering of light. So when it will spread, when light spreads in all directions, that means what? When scattering of light occurs. When scattering of light occurs, as you know, when light from the sun enters into the Earth's atmosphere, as you know, Earth's atmosphere consists of water, dust particles and air molecules, right or not? So dust particles and air molecules. So because of this, what happens is these dust particles and air molecules, what they do is they absorb this light energy and they re-emit this light energy. What is that? They absorb this light energy and re-emits this light energy in all the directions by the dust particles and air molecules of the atmosphere. So this is called it as a, what is that? Scattering of light. Who is responsible for this scattering of light? Who is responsible? Atmosphere. Atmosphere consists of what is that? Dust particles and molecules. So dust particles and molecules. What these are doing when light enters into the atmosphere? What these are doing? These are absorbing this light energy and they are re-emitting this light energy in all the directions by the, what is that? That is what is taking place? Scattering. So scattering is a process of absorption of light energy and re-emission of this light energy by whom? By the dust and air molecules of the atmosphere. So this is called it as a, what is that? What is that? Scattering of light. So in this scattering of light, who is responsible? This air molecules and the dust particles. So that means here the molecules, that means the size of molecule is going to show its influence on scattering of light. That means what? Size of the molecule is a factor for the, what is that? Scattering of light. What is this? If the size of the molecule is smaller than the wavelength of the light. Who is scattering here? Light scattering means what? Light colors of the light. Definitely whenever color come into the play or whenever we are talking about the light, we need to talk about the wavelength of the light, right or not? So that means what? We are going to see what is how the scattering is taking place in the atmosphere. Then means what? In the atmosphere, molecules and dust particles are there. The size of the molecule matters for the scattering of the light. Okay, factor for the scattering of the light. So size of the molecule and wavelength of the light. If the size of the molecule is smaller than the wavelength of the incident light, so when the size of the molecule is less than the wavelength of light, wavelength of light. What is going to happen now? Wavelength of the what is going to happen? The incident, what is that? It absorbs the energy, incident light energy, and what are then re-emit without any changes in the wavelengths. So again, what is the size of the molecule is less than the size wavelength of the light. What happens? Incident light energy will be absorbed and re-emitted without any change in its wavelengths. So now the scattering of light is not same for all wavelengths of the light. So that means what? Different wavelengths. Different wavelengths, when we say, what does it mean? Different colors. That means what? In a visible spectrum. In a visible spectrum. What is visible spectrum? Visible spectrum VIBGR, right? VIBGR. So what is this? Violet is having least wavelength. How much? Approximately 4000 angstroms. What about red? Red is having most wavelength. What is that? Approximately, what is that? 8000 angstroms. So because of this reason, violet color scatters most. So scattered, what is that? Violet color, the scattering of the violet light is more, and the scattering of the red light is less. I hope it is clear. So what I want to tell you here is wavelength. When size of the molecule is less than the wavelength of the light, what is going to happen? Incident light energy will be absorbed and again re-emitted without any changes in the wavelength. The intensity, what I'm saying, the scattering is not same for all wavelengths. It is different for different wavelengths. So here wavelength of what is that? Violet color is 4000 angstroms. Red is what is that? 8000 angstroms. So what is going to happen here? Violet is going to scatter more and red is going to scatter less because of the least wavelength of the violet, most wavelength of the red. Okay, yeah, because of that only, if you see in the formation of rainbow, also, you can see what is that is called violet color less intensity and red color you can see more intensity. I hope you have observed. So here that is what about the different for the different, who is different, scattering is different for the different colors of different lights. Okay, so what is this? Let us look into the relationship between the intensity of the light and wavelength. So the intensity of the light is inversely proportional to which light? Scattered light. So the intensity of the scattered light is inversely proportional to the, what is that? 1 by lambda power 4. What is that? Intensity of the light, scattered light, is inversely proportional to the, what is that? Fourth power of the wavelength of the light. Fourth power of the wavelength of the light. What is this? I for intensity of the light, lambda for wavelength. What is I here? What is that? Intensity of which light? Scattered light. What is lambda? Lambda for what is that? Wavelength. So wavelength, what is that? Intensity of the scattered light is inversely proportional to the, what is that? Fourth power of the wavelength of the light. So this is the relationship. With this we can understand the intensity of the scattered light and wavelength. Yeah. Then what about size of the molecule is more than the wavelength of the light? So when size of the molecule is less than the wavelength of the light, what is happening? Energy absorption takes place and re-emitted without any changes in the wavelength. But this, that is only we call it as a scattering. But this scattering is not same for all the colors. So the scattering of the light depends on what? Wavelength of the color. So now what about if the size of the molecule is more than the size of the molecule is more than the size wavelength of the light? What happens? Size of the molecule is more than the wavelength of light. wavelength of light. What happens when it is size of the molecule is more, that means what, bigger than the wavelength of the light, what happens here, the scatter what happens, light the scattering of the light of all the wavelengths of white light to the same extent. That means what, the scattering of all the colors is going to be same. So it is going to be same for all the colors. When the size of the molecule is more than the wavelength of the light, what is going to happen, the scattering is going to be same for all colors. Yeah, so this is what about scattering of light. Yeah, in the next video we are going to understand applications of scattering of light. Here we have some applications of this scattering of light. That means because of the scattering, there are the beautiful processes are taking place in our atmosphere, that we are going to understand in the next video. Yeah, thank you for watching this scattering of light video from P&M Tuitions. Yeah, thank you once again.